Welcome to this deep dive where we unpack the latest and most impactful research in machine learning.
Glad to be here.
Today we're tackling a paper that's really pushing the boundaries of how multimodal large language models, the ones that get both images and text, can truly reason.
Yeah, it's a hot area.
And you, our listener, you know how fast this field moves. Staying ahead means understanding not just what these models can do, but well, how they're learning to do it better.
Exactly. We've got our hands on a really fascinating study. It digs into a core challenge, getting these MLLMs to go beyond just like pattern matching with pictures and words.
Right, to actually think.
To actually engage in some sophisticated reasoning, yeah. So this deep dive, we'll explore how a new reinforcement learning approach might unlock a new level of self-improvement in how these models reason.
Okay, sounds good. The paper we're digging into is called R1-VL. Learning to reason with multimodal large language models via stepwise group relative policy optimization. Bit of a mouthful.
Yeah, they often are. R1-VL and Step-GRPO are probably the key things to remember.
Got it. R1-VL, Step-GRPO. So let's get into it. The researchers start by highlighting a key problem, right? A limitation in how MLLMs usually get trained for reasoning. They point out that just using supervised fine-tuning with that chain of thought data basically showing the model loads of examples of correct reasoning, well, it can lead to imitation, like the model mimics the steps but doesn't really get it.
That's a great way to put it. It's like learning a maze by only seeing the one correct path. You memorize it, maybe?
But you don't learn why the wrong turns are wrong.
Exactly. The paper argues this kind of passive learning stops the model from really exploring different ways to reason and, crucially, learning from its mistakes.
Okay, so they need a way for the model to sort of try things out.
Precisely. And that's where they introduce stepwise group relative policy optimization, or Step-GRPO.
Step-GRPO.
It's an online reinforcement learning framework,
Right.
which basically means the model learns by trying out different reasoning paths and getting feedback as it goes.
So it's not just about the final answer being right or wrong anymore. It gets feedback during the process.
That's the key idea.
Because I seem to recall that applying RL to something this complex, like multimodal reasoning, it hits problems. Sparse rewards, is that the term?
Absolutely, spot on. Sparse rewards are a major hurdle. In, let's say, traditional RL for tasks like this, the reward signal often only comes right at the end.
Like correct or wrong.
Exactly, just a binary signal. And for complex multi-step reasoning, mixing vision and language, that final thumbs up or thumbs down is often, well, too little, too late.
It doesn't guide the steps that led there.
Right. It's like imagine learning a complex piano piece and the only feedback you get is at the very end. Perfect or nope. No feedback on timing, notes, fingering, nothing along the way.
Yeah, that wouldn't be very helpful for learning. The model could fluke a right answer with bad logic or make one tiny mistake early on that messes up the whole thing.
That's the crux of it.
Yeah.
So how does Step-GRPO get around this sparse reward problem?
Okay, yeah, what's their solution?
This is really the core innovation of the paper. Step-GRPO brings in two new rule-based rewards that give feedback at each step of the reasoning.
Each step.
Yeah. The first one is called Stepwise Reasoning Accuracy Reward, or Step-RA.
Step-RA. Accuracy. Got it.
This reward basically encourages reasoning paths that actually include the necessary intermediate steps. The researchers use this neat soft key step matching technique.
Soft key step matching.
Yeah. It compares the steps the model generates against crucial steps they've extracted from high-quality reasoning examples. Think as essential variables or equations for a math problem.
Okay.
And importantly, to make it more flexible, they generate these key steps in different equivalent ways, different ways to write the same equation, for instance.
Oh, I see. So even if the model words an intermediate thought a bit differently, as long as it captures that core logic, it still gets recognized. It gets the reward.
Exactly. It makes the matching much more flexible and robust.
That sounds much better.
Yeah.
Okay, what's the second stepwise reward?
The second one is the Stepwise Reasoning Validity Reward, or Step-RVR.
Validity, okay.
This one's focused more on the overall structure and logical flow. Does the reasoning make sense as a whole?
How does it measure that?
It looks at two things. Reasoning completeness. Did it include all the necessary parts, like analyzing the background, the step-by-step working, and a final answer?
Right. You need all those bits.
And also, reasoning logic, are those parts in the right order? You need to understand the problem before you start solving it, and the answer should come at the end.
Makes perfect sense. So it's not just about getting the individual steps right with Step-RVR, but Step-RVR makes sure they're put together in a logical, complete way.
Precisely. You need both the right ingredients and the right recipe.
Okay, so how do they actually implement this? How does the training work with Step-GRPO?
Right, so it unfolds in two main phases. First, there's a policy warm-up phase. Here, the MLLM gets an initial training round using standard supervised learning. They feed it a data set of multimodal problems that come with those chain of thought reasoning paths.
So this is like the basic training, getting it familiar with the task, the types of problems.
Exactly. It gives the model a foundation, some basic ability to reason about these things.
Okay, so it learns the basics first, and then it starts refining its own reasoning using these stepwise rewards.
That's phase 2, stepwise online policy optimization. Now, for each problem, the warmed-up model generates multiple different reasoning paths, tries different ways to solve it.
Oh, interesting. Not just one path?
Nope, several. And then Step-RVR and Step-RVR kick in to evaluate each of those paths step by step, giving those detailed rewards.
Right.
And here's a clever bit. They use the average stepwise reward across the whole group of paths for that one problem as a baseline.
A baseline? Why?
It helps the model figure out which of its own attempts were relatively better or worse than its average performance on that specific problem. This advantage calculation then guides the update.
So it's comparing its own reasoning strategies against each other.
Kinda, yeah. The model's internal strategy, its policy, gets updated using a reinforcement learning loss function based on this. But there's another important piece.
What's that?
They include a KL divergence term in the update.
KL divergence. Okay, keeping it somewhat technical, what does that do?
Yeah. Basically, it acts like a regularizer, a constraint. It prevents the model from changing too drastically, from straying too far away from the good stuff it learned during that initial warm-up phase.
I see. So it encourages exploration through the RL rewards, but the KL term keeps it grounded, stops it from forgetting the fundamentals it already learned, like a safety rail.
That's a good analogy, a safety rail. It balances exploring new reasoning methods with retaining existing knowledge. It's about refinement, not starting from scratch.
Okay, that makes a lot of sense. It's a smart way to balance exploration and stability. Now, the paper mentions R1-VL. That's the model they built using this, right?
Yeah, R1-VL is the name they gave to the series of MLLMs they developed using the Step-GRPO framework.
And did they test it? How did R1-VL actually perform?
Oh yeah, they put it through its paces, extensive experiments on 8 different benchmark data sets. Yeah, and many of these are tough benchmarks specifically designed to test things like mathematical reasoning, visual reasoning, understanding charts, complex multimodal stuff, MathVista, MMStar, MathVision, Chart2, a whole suite.
Okay, the moment of truth.
Yeah.
Did Step-GRPO actually make R1-VL better at reasoning?
The results look really strong. Across the board, R1-VL showed significant gains. It outperformed other state-of-the-art MLLMs on these tricky reasoning tasks.
Really? Outperformed existing models?
Yeah, and what's particularly interesting is that even their smaller 2 billion parameter model, the R1-VL2B, it managed to beat much larger models that were trained just using the standard supervised fine-tuning approach.
Wow, that is impressive. So size isn't everything here. The training method really matters.
It certainly seems that way, especially for these kinds of tasks. Mathematical reasoning, for example, needs really strict logical steps, and you need to be able to recover if you make a small error.
Right.
And that stepwise feedback from Step-GRPO seems to give it a real edge compared to just looking at the final answer.
Yeah, that detailed guidance seems crucial. So it suggests this targeted step-by-step feedback is maybe more effective than just throwing more parameters for more data at the problem with the old methods.
It points in that direction, definitely. The paper also dives into what they call ablation studies.
Ablation studies, meaning they took bits away to see what happened?
Exactly. To figure out which parts of Step-GRPO were doing the heavy lifting, they ran experiments turning off Step-RVR or turning off Step-RVR.
What did they find?
They found that both Step-RVR, the accuracy reward, and Step-RVR, the validity reward, individually helped improve performance.
Okay.
But crucially, using both together gave the best results, which really underlines the idea that you need both correct individual steps and a sound overall structure for top-notch reasoning.
Makes sense. Both matter. Did they test anything else?
They also looked at the number of reasoning paths generated in that online phase. when the model tries multiple solutions.
Yeah, the group comparison thing.
Right. They found that generating a small group, like maybe 4 or 8 paths, generally worked best for stable learning. Too few, and maybe not enough comparison. Too many, and maybe diminishing returns or instability.
Interesting. So there's a sweet spot. It's almost like the model learns best by having a small internal focus group of its own reasoning attempts.
That's a neat way to think about it, yeah. Comparing its own work helps it improve.
Okay, so the paper also puts this into context, right? Historically speaking.
Yeah.
Where does Step-GRPO fit in the big picture of AI reasoning and MLLMs?
Yeah, understanding the context is important. I mean, getting AI to reason complexly is a super old goal, right? Goes way back.
Decades. Rule-based systems and all that.
Exactly. Early stuff was often brittle, rule-based systems. Then machine learning came along, learning from data, huge progress there. In NLP, we saw LLMs and then chain of thought prompting big leaps for reasoning.
Yeah.
But as this paper argues, just fine-tuning on those chains of thought, the supervised approach, it often leads to that mimicry problem we talked about.
Learning the script, but not the acting technique.
Kind of. More recently, people started using online reinforcement learning, like GRPO, for pure language models to improve reasoning, often using just that final outcome reward.
Okay.
But trying to just port that directly over to multimodal models ran smack into that sparse reward issue. Multimodal reasoning chains are often longer, more complex. Getting that final correct signal is just much harder, especially for smaller models.
So the signal is too weak, too infrequent to learn effectively from.
That's the problem, and Step-GRPO is positioned as a solution specifically for that. It tackles the sparse reward problem in MLLMs by giving that denser, more frequent feedback at each step.
Gotcha. So Step-GRPO is kind of bridging that gap, bringing the trial and error learning of RL to the complex multimodal world where simple end result feedback just isn't enough.
Precisely. By breaking down the reward, giving those stepwise signals, it guides the learning much more effectively.
And you mentioned it doesn't need a separate reward model.
Right, that's a practical plus. The rules for Step-RR and Step-RVR are defined based on the reasoning process itself, checking for key steps, checking the structure. It avoids the complexity of training yet another model just to provide rewards.
That seems more efficient.
Yeah.
Okay, let's shift gears a bit. Thinking about the future, what are the real-world implications here? If we get MLLMs that reason better using things like Step-GRPO, what changes?
Oh, the potential impacts are pretty broad, I think, quite significant.
Like what?
Well, imagine AI assistants that are just much more reliable. You give them a complex task involving, say, analyzing a chart and some accompanying text. They could reason through it more accurately, give you better support.
Okay, more reliable assistants.
Think about education. An AI tutor that doesn't just give the answer to a complex math problem involving a diagram, but can actually explain the steps, the logic, tailored to where the student might be struggling.
That would be powerful.
Or in research, helping scientists analyze complex visual data, like satellite images or microscope slides, combined with text data, drawing more robust conclusions.
Yeah. Medical imaging.
Definitely. Helping radiologists, perhaps, not just flagging an anomaly in an X-ray, but maybe outlining the reasoning steps that point towards a particular diagnosis, combining image features with patient history text.
And document understanding. Pulling information logically.
Exactly. Deeper analysis, more logical extraction from complex documents that mix text, tables, images, basically anywhere you need detailed visual analysis and logical inference combined.
So ultimately, it's about building more trustworthy, less error-prone AI for jobs where getting the reasoning right really matters.
That's the goal, yeah.
Right.
It's moving towards AI that doesn't just recognize things, but can genuinely reason about them. It could really reduce those frustrating moments where AI just doesn't seem to get the visual nuance combined with the question.
It definitely feels like a solid step towards AI that understands the world more like we do. Okay, let's move into our novel notions segment. Time to brainstorm a bit. Take these ideas and run with them.
All right, let's get creative. So, building on this core idea, rewarding intermediate steps, what if we applied that not just to logical reasoning, but maybe to, say, creative tasks?
Creative tasks, like generating art or music.
Yeah, specifically creative content generation grounded in visual input. Think about an MLLM generating a sequence of images, maybe aiming for a particular artistic style based on a text prompt.
Okay.
Instead of just judging the final images, which can be super subjective, what if we tried to define key artistic steps?
The artistic steps, what would those look like?
Well, maybe things we can measure or at least identify at intermediate stages, like specific textures appearing or certain compositional rules being followed, or the color palette shifting in a way that matches the target style.
Ah, so you'd reward the model for hitting those stylistic milestones as it builds the image.
Kind of, yeah. Rewarding it for incorporating those stylistic building blocks correctly along the way.
So instead of just make a Van Gogh-style picture of a cat, you might reward it for first getting the basic cat shape, then for applying those characteristic swirling brushstrokes, then for getting the color palette right.
Exactly. That's the kind of idea. Now, the big challenge, obviously, is defining those key artistic steps and valid artistic progression with rules. Art is subjective.
Way more subjective than math proofs.
For sure.
But
But maybe you could say, train another model first, an analysis model, to identify key features of a given style from lots of examples.
right.
And that analysis could then help design the stepwise rewards for the generative MLLM.
Interesting. So you'd use AI to help define the rules for training another AI.
Potentially. It could lead to models with much more nuanced control over their creative output, moving beyond just basic style transfer towards a deeper application of artistic principles. It makes the AI feel more like a controllable creative tool, maybe even a partner.
That's a really cool extension, applying stepwise rewards beyond pure logic. Okay, what about another notion?
Well, another direction could be integrating human feedback more directly into this Step-GRPO framework.
Human feedback, how?
Right now, Step-RVR and Step-RVR are rule-based, which is efficient, but rules might miss nuances. What if, instead of, or maybe in addition to the rules, humans evaluated the intermediate reasoning steps?
So people would look at the model's step-by-step working and rate it.
Yeah, they could give feedback on the clarity, the correctness, the logical flow of individual steps, not just the final answer.
Like reinforcement learning from human feedback, RLHF, but focused on the process, not just the outcome.
Exactly. You can imagine a hybrid system. Maybe start with the rule-based rewards to get the model going, then bring in human annotators for finer tuning, catching things the rules miss, like, is this explanation clear? Is the logic easy to follow, even if technically correct?
That could capture more subjective aspects of what makes reasoning good.
It could. Of course, the challenge there is scalability and cost. Getting humans to review lots of intermediate steps is expensive.
Yeah, that's always the issue with human-in-the-loop stuff. But it's an interesting idea for potentially creating even more robust and maybe human-aligned reasoning.
Definitely something worth investigating. How to best combine automated rule-based feedback with richer human judgment.
Absolutely. Okay, that brings us towards the end of this deep dive. So, key takeaways. Step-GRPO looks like a really promising way to boost reasoning in MLLMs.
Yeah, by tackling that sparse reward problem head-on with these stepwise rewards, Step-RR and Step-RVR.
Giving that more granular feedback seems key, especially for complex tasks like mathematical reasoning.
And the results with R1-VL suggest it really works, even letting smaller models punch above their weight.
For sure. It definitely feels like a solid contribution towards making these multimodal AI systems more capable and hopefully more reliable.
Agreed.
As always, we encourage you, the listener, to check out the paper itself. The link for R1-VL, Learning to Reason with Multimodal Large Language Models via Stepwise Group Relative Policy Optimization, is in the show notes. It's worth a read for all the details.
Definitely.
And it leaves you thinking, doesn't it? As these AI systems get more complex, how do we keep refining their ability, not just to process data, but to genuinely understand and reason about the messy, complex world we live in?
That's the big question, isn't it? This paper is one step, but there's a long road ahead.
Indeed. A question to ponder. Thanks for joining us on this deep dive.
My pleasure.